Hi dear students, this is BS Academy Grade 10 Physics. In this video we are going to discuss what is principal focus. Okay, right. See, to understand this, let us draw the concave mirror. So this is concave mirror. This is the faded part of the concave mirror. And we already discussed what is this point, student. This is pole. Okay, so that is the center of the reflecting surface. This is pole represented by the symbol P. And the center point of the spherical surface, that is the center point of the sphere, that is represented as what? Center of curvature, right? And we already know the imaginary line which is passing through the center of curvature and the pole is called as what? Principal axis. So this is the imaginary line passing through the center of curvature and pole. This is called as what? Principal axis. And this distance, that is this distance, is called as radius of curvature. That is the radius of the sphere. That is radius of curvature represented by the symbol capital R. Okay, we already discussed all those things in the last video itself. Okay, right. Now see, to understand the principal focus, you imagine that some parallel rays are falling on this concave mirror. So see, these are the parallel rays, light rays. So consider some two parallel rays which is incident on the concave mirror. So this is the incident ray which is falling on the concave mirror. So we will know what happens. Reflection will takes place. So this incident ray, after it gets reflected, it passes through some particular point, that is like this. So this is the reflected ray. So the incident ray falls on the concave mirror and it reflected like this. And same way, see, consider another incident ray, and this is incident over here, and what will happen here also, it gets reflected like this. Okay, right. So this is one of the reflected ray and this is the another reflected ray, right? Here now we can observe that these reflected rays are meeting at the same point. So this point at which the reflected rays meet, this point at which the reflected rays meet is called as the principal focus. Okay, see the definition. The point at which the reflected rays meet is called as what? Principal focus, right? Now what is this appears to meet? See, for concave mirror, actually the reflected rays are meeting at a particular point, and this point is called as principal focus, and this principal focus is represented by the symbol, that is capital F. So this point is represented as capital F, that is principal focus. Okay children, right? So this is for concave mirror, right? Same way for convex mirror. See, for convex mirror, this is convex mirror, no? We know this is the faded part of the convex mirror, and this is pole represented by the symbol P. And I already told you the center of curvature of the concave mirror, it lies in the right hand side. Okay, it lies in the right hand side. So this is the center of curvature, and the imaginary line which passes through the pole and the center of curvature is called as the principal axis. Okay, it is called as the principal axis. So this line is called as principal axis, and we know this is the radius of curvature. This distance is called as the radius of curvature. Okay, right. Now see, same way as we discussed in the concave mirror, here you consider the parallel rays which is falling on the convex mirror. See, these are the parallel rays which is falling on the convex mirror like this. So what will happen? The incident ray which falls on the convex mirror will get reflected back. See, for concave mirror, the rays get converged. It get converged and it meets at a particular point, Okay, but for convex mirror the rays get diverged. So it get reflected back like this. It reflected like this. It get reflected like this. It get diverged. Okay. Same way, see here, this incident ray will get reflected like this. It get diverged. The rays are diverged. Okay, right. Now see then how to find out the meeting point of the reflected rays in case of the convex mirror. See, for that you have to just extend this in reflected ray. So this reflected ray is extended like this, and that extended line or the extended ray of the reflected ray, it will meet at a particular point. So this reflected ray is also extended, and these points will meet at a particular point, and this point is called as what? Principal focus. So that is what the definition is given over here. The point at which the reflected rays meet. Okay, in case of concave mirror it actually meets, but in case of convex mirror it appears to meet. Okay, it appears to meet at this particular point, and that point is called as what? Principal focus. It is represented by the letter capital F. Was it clear, students? So this is for concave mirror and this is for convex mirror. Okay, is it clear? Right. Now see the next definition, that is focal length. The focal length is defined as, see, the distance between the pole and the principal focus of a spherical mirror is called as the focal length. See, refer the same diagram. The distance between the pole and the principal focus. This is the principal focus, no? Right? So the distance between the pole and the principal focus is called as the focal length. So it means this distance. So this distance is called as what? Focal length. And the focal length is represented by the symbol small f. Okay. See, for convex mirror, the distance between the pole and the principal focus, it means this distance. This distance is called as what? Focal length, and it is represented by the letter small f. Okay. So see, this is focal length, between distance between the pole and the focus. This is focal length, distance between the pole and the focus. So see the definition. The distance between the pole and the principal focus of a spherical mirror is called the focal length, and it is represented by the letter small f. Okay, be clear about these, children, because see, capital F is nothing but what? Principal focus. Capital F is principal focus. Okay, and small f is what? Focal length. Small f is focal length. Is it clear, children? Right? So be clear about the principal focus and the focal length. Right? Now see, from the diagram we can able to find out relation between the radius of curvature and the focal length. See, this is the focal length. Now this distance is focal length. Now from the diagram we can say that this distance is equal to this distance. It means the distance between F and P is equal to the distance between F and C. So this distance is equal to this distance. So if this distance is called as focal length, and this distance is also equal to the focal length, that is F, small f. Okay, right? So if this is F and this distance is also equals to the same value, that is F. Okay, and we already know this total distance, that is the distance between C and P, is called as what? A radius of curvature. It is called as radius of curvature, right? So from the diagram itself clearly we can able to note that this radius of curvature, this total distance radius of curvature is found to be equal to twice the value of the focal length, right? So this whole distance is equal to twice the value of this focal length. Okay, is it clear, children? Right? See, the radius of curvature is equals to twice the focal length. Okay, right? See, by using that observation, we can able to write that radius of curvature R is equals to 2 times of focal length. Okay, this is very much important relation between the radius of curvature and the focal length. By using this formula, we are going to derive the numerical problems also. So be clear about this. So R is radius of curvature and small f is the focal length. What is the relation between the radius of curvature and focal length? See, the radius of curvature is equals to twice the focal length. Okay, and if you want to note down the, if you want to find out the value of focal length from this formula, see, you can write it as f is equals to radius of curvature divided by 2. Okay, focal length f is equals to radius of curvature divided by 2. It means what? Focal length is half the value of the radius of curvature. Is it clear, children? See, focal length is half the value of the radius of curvature. Okay, children, right? So be clear about these two formulas which we are going to use while we are deriving the numerical problems. Okay. So be clear about these topic, that is principal focus and the focal length and the relation between the radius of curvature and the focal length. Okay, children, see you in the next video. Thank you.